Today's topic is transformation of functions. Specifically, we will look at vertical and horizontal shifts, which are also called translations. Have you ever wondered how when you're working in, let's say, a Word document and you want to cut and paste some text and you have to move it to a different position, how that's happening? Well, we're actually going to look at the mathematics behind that today, because generally when you cut and paste, you're moving things either up and down, left or right, or a combination of those. And that's exactly what we're going to look at today with vertical and horizontal shifts of functions. So our objectives are to understand and describe how the graph of f of x plus c relates to the graph of f of x, understand and describe how the graph of f of quantity x plus c relates to the graph of f of x, and perform a combination of these two changes. So the first objective, focusing on f of x plus c, where c is a real number. So this is taking an original function and adding a value to it. So let me take a step back and just review a few things with you. In this section, when we talk about f of x, primarily we're going to look at f of x as one of those basic functions that we've talked about before. So as an example, if f of x is equal to the absolute value function, let's just look at what f of x plus c would even look like. So let's say that f of x plus c then is going to be absolute value of x plus some number. We're just adding a number to it. So for instance, if c is equal to 2, f of x plus 2 would simply be absolute value of x plus 2. If c is negative 3, f of x minus 3 would be the absolute value of x minus 3. So our goal right now is to understand when we change the original function by adding or subtracting a number to it, what happens to that original function. And we have the handy dandy calculator, so let's turn that on and take a look and see what's going to happen here. So let's look at the function that I just spoke about, absolute value of x. So I'm going to press y equals key, and remember, to get to the absolute value, what you have to do? Yeah, you need to press the math key and arrow to number and select option 1 as absolute value. And I always like to graph the absolute value function, or that basic function, first. And in the window that I have here, it's going to be displayed. Remember, it's that V-shaped graph. Now let's take a look at the ones that I just talked about. Let's do the absolute value of x plus 2. There's a couple ways you can enter that. One way is simply that. We can say absolute value, so remember, good math, 1 absolute value of x, be sure to close that parentheses, and then add the 2. So let's see what happens. Notice that whenever we graphed that, absolute value of x plus 2 is that original absolute value of x, but now it's shifted vertically. It is shifted up 2 units. Another important thing is to notice this, that in the table of values, when we add 2, what's changing? Notice how every y value is increased by 2. So what we're saying is when we add a value, we are vertically changing it by that quantity. In other words, that is affecting the y values only. The x values are not changed. We're just increasing the y value up 2 units. What happens if we do absolute value of x minus 3? So now let's go back up here and change this. Okay, and let me press enter. Did you see what happened now? Okay, this is our original absolute value, but now absolute value of x minus 3, what happened? It is shifted down 3 units. And that's true, we see in the ordered pairs, right? It was originally negative 3, 3 on y1, but now it's negative 3, 0 on y2. 1, 1 is on the graph of y1, but now it's 1, negative 2 on the graph of y2. So what can we conclude here? That when we look at f of x plus c, let's do this in two cases where c is positive, that will shift the graph of f of x up c units. F of x minus c, where c is negative, will shift the graph of f of x down c units. Okay? So let's take a look at just a couple more examples. Let's say that we have this. Y is equal to x squared plus 4. And what you should do is tell me, how does this compare to a basic function? And first of all, what is that basic function? And then describe the change that this graph has to that basic function. Well, the basic function, hopefully you can recognize this, is this x squared. So our basic function is y is equal to x squared. So what then would be the effect of y is equal to x squared plus 4? In other words, how would the graph of this compare to the graph of y is equal to x squared? Anybody know? Right, we're adding a number plus 4. So we would expect that that graph of y is equal to x squared is going to shift up 4 units. Well, what is the graph of y is equal to x squared? I hope you understand those basic functions. The shape of y is equal to x squared was that parabola, right? So when we shifted up 4 units, remember we had that vertex point at 0, 0. When we shifted up 4 units, we're going to find that that vertex point is at 0, 4. And we can confirm that on the calculator, right? If I clear out what I have here. Okay, let's say that I have y is equal to x squared. Would help if I typed in the right one, wouldn't it? X squared. And then we do x squared plus 4. I apologize. This tablet is being very sensitive here. Okay. There we go. Finally, it took over. Y is equal to x squared plus 4 shifts that graph of y is equal to x squared up 4 units. Now, what does that do to the domain and range? Yeah, my domain is unaffected because I'm really not changing the x values at all, but my range is affected because I'm affecting the y values. So the range in this, remember, is our bottommost point. What did somebody say? 0 to infinity? No, remember that range is the y values. So we would have to start from 4 to infinity. Always describe your y values in the range. Okay, so we would say that y is equal to x squared plus 4 is a vertical shift of y is equal to x squared by 4 units upward. Now let's take a look at f of x plus c. And again, let's take a look at what does that even mean. Do you remember evaluating a function we talked about before, that whatever's inside parentheses is going in place of the x? So let's take a look at some of the basic functions and how that would look as a final result. Let's say we have a basic function of f of x is equal to the square root of x, right, our square root function. What does f of x plus c mean to do? Well, this would mean that I'm going to replace the x with x plus c. Okay. So now that change, that c value per se, is actually being affected by that function rule. Whenever we added a number to a function, we really weren't changing the value of x, right? We were changing the y value. So it was like you calculate the x and then you have to move it up or down. Well, here you have to do something to the inside piece before you actually apply the function to it. So this one will affect the x values either left or right. And we'll see that. Let's take a look at what happens if we have f of x plus 5, for instance. So f of x plus 5 would mean to do the square root of x plus 5. What if we have f of x plus, I don't want to do plus here, let's change that to minus. F of x minus 6 would be the square root of x minus 6. So let's go to the calculator and see what these changes have on the original function. Okay, so there we go. I wanted to put in the square root of x as my basic function. And then our next function was what? The square root of x plus 5. Now, you remember how when we added a number, it changed it by the way we thought. In other words, if we added a positive number, it shifted it up. If we added a negative number, it shifted it down. Well, let's see what happens when we do this to the inside. My calculator wants to run slow this morning. Okay. It's hard to see here because of the square root function, but remember our basic square root function here? Notice what's happening when we put in the square root of x plus 5. It shifted it in which way? Not right, but left. Right now we're at this point negative 5, 0. Now why is there error here? Do you remember that? You can't take the square root of a negative. It's an imaginary number, so that's why we see that error message in our chart. But notice that the y values are still the same, aren't they? So we're not really affecting the y values in this case. What's happening is the x value that produces that y value. So for instance, like the x value of 2 made a y value of 1.414. But now, what is producing that same effect on the new function? On the new function, it is negative 3 is producing that same y value. So in other words, we had to shift it in the negative direction to get the same effect in the y. And so this one shifts left by 5 units. Well, let's see what happens when we subtract a number on the inside of that radical. What was that? Minus 6. Take a minute for that to perform. Okay. Now notice to see what happens. My original function is here, but my shifted function is to the right. Again, why is that? Because now it takes 6 more to produce that same original y value that I had. And if I go to the table and actually scroll down, you'll see that a little bit better. Okay. On my original function 1 was there. But now on my new function, it takes an x value of 7 to produce that same y value. And you can see, isn't this really interesting, that all the y values are staying the same, right? Again, what's changing is the x value that produces that. And so whenever we have a change of this form, we call that sometimes an inside change, right? Because we're changing the value of x before the function is applied to it. This is going to be a horizontal shift, left or right. And in fact, we'll say this, for f of x plus c, where c is negative, okay, in this case, this shifts f of x c units to the right. If we have f of x plus c, where c is positive, that will shift f of x c units left. Sometimes what I do, think about what value makes the inner piece 0, and that's how you know if you need to go right or left, because it's really the opposite, right? X plus 5 equals 0 at negative 5, so it's going to shift it left 5. X minus 6 is equal to 0 at positive 6, so it's going to shift it right 6. So let's talk about this change then. If we have y is equal to x minus 4 cubed, what basic function is changing and how is that basic function changing? Well, the basic function is this cubing, right? Y is equal to x cubed. So how does y is equal to x minus 4 cubed relate to that basic function? Okay, so it's minus 4. So this means we're going to shift y is equal to x cubed. What would you say, right or left? So think about what makes this 0. Yes, 4. So this is going to shift y is equal to x cubed right 4 units. Now you can check that on the calculator. How would that impact our domain and range? Well, shifting right is only affecting the x values, right? And our domain for the cubing function is all real numbers, so our domain is still all real numbers. If you shift that left or right, you're still going to get all real numbers. And the range of the cubing function, do you remember what that is? Yes, it's going to be all real numbers as well. It's really, in this previous problem, like the radical function, square root function, where my domain was not all reals, that you're going to see more of an effect with the domain. Do you remember this? The square root of x plus 5, its domain would be, since it shifted at left 5 units, its domain would be from negative 5 to infinity, because the domain of the square root function is 0 to infinity. So the domain of the square root of x minus 6 would be 6 to infinity. And the range is not affected there. Now, for a combination of these changes, it's going to look like this. Let's say y is equal to the square root of x minus 2 plus 4. So you have to tell me, how is the basic function changing? And you have to recognize the basic function, any inside change and outside change, so to speak. Well, the basic function is y is equal to the square root of x. So notice that we have two changes. We have this inside change and this outside change. The outer number is going to be the number that shifts it up or down. The inner number shifts it left or right. So this is taking y is equal to x squared and doing what? Shifts it right or left? Not left, right? Because x minus 2, what makes that 0? Positive 2. So it shifts it 2 units right. And what about this outside change? And 4 units up. Okay. And we can see this on the calculator. Let me go back to y is equal to the square root of x. And what is that? I had the square root of x minus 2 close the parentheses, plus 4. And now graph. Yep. So it shifted over and up. Over and up. How's the domain affected? Yeah, the domain is affected. The domain of this new function is shifted right 2 units. So the domain is 2 to infinity. The range is shifted up 4 units. So now it is 4 to infinity. Okay, so some pretty cool stuff. If you have any questions about this, be sure to watch the homework video that I have and also on the calculator video. And please email me if you have further questions. Thanks and have a great day.